Hey guys, welcome back to Algebra 2. Today we're going to be looking at 2.7 absolute value functions and transformations. And this podcast is for Eleanor. Let's take a look at the absolute value functions. The graph of an absolute value function is V-shaped and it is symmetric about the y-axis. In other words, the y-axis acts as a mirror and reflects the graph. Thus, for every point xy on the graph, the point negative xy will also be on the graph. And I'll show you that in just a minute. This function, f of x is equal to the absolute value of x, is what we call the parent function of all absolute value functions. And it's the parent because it's had no transformations, and so it goes through the point 0, 0, 1, 1, 2, 2, so on and so forth. And because of what we said over here with that symmetry, it also goes through the point negative 1, 1 and negative 2, 2. Now, this point on your absolute value function is called the vertex. And on the parent function, it just so happens that the vertex is at 0, 0. And you'll want to remember that because it's helpful and it helps you to graph other functions later on. So the vertex of an absolute value function is either the lowest point if the graph opens upward, or the highest point if the graph opens downward. So these are both vertices. Okay? Let's take a look at what I just mentioned, which is the transformations. Now, a transformation is a change in a graph's size, shape, position, and orientation. What we're going to look at right now is a translation, which is a type of a transformation that only changes the position horizontally and or vertically. So we're just going to change it horizontally or vertically. We're not going to change the size or the shape or the orientation. So here I have the parent function again, and I have it graphed in blue. And you can see again it goes through the point 0, 0, 1, 1, 2, 2, negative 1, 1, and negative 2, 2. But what I want to graph now is I want to graph the second function. F of x is equal to the absolute value of x minus h plus k. Now you might be wondering, since I don't have any numbers in there, how I'm going to graph it. Well, this is how the translations work, and this is what you need to understand about how to use the h and the k to create those translations. This h is actually going to be your horizontal shift. So whatever that h is, that's going to tell you what the horizontal shift in your graph is. And I'll actually show you how to do that in just a minute. Now the k is your vertical shift. And we're going to be using these a lot, so you need to know that. So the way I do this is I take the vertex of my parent function, which is at 0, 0, and I use it to make my shifts. So I'm going to shift it horizontally, h units. And we don't know what h is, so we're just going to pretend like that's h. And then I'm going to shift it vertically, k units. And again, that's my k units. And because of that, I now know my vertex of the new function is at hk, which is really handy. Again, these two values create your vertex. Now, some of you might be thinking that I graphed my horizontal shift backwards because this says minus h. But you always go horizontally in the opposite direction that it appears. So this looks like a negative h, so my horizontal shift is actually a positive h units. And your teachers and I can talk about that in class when you see you again if you have questions there. But the horizontal shift is always the opposite of how it appears, and the vertical shift is exactly the same as it appears. So let's take a look. Let's try an example. So again, what I like to do is I like to graph, just sketch in, not actually even graph, the parent function. So I'm going to sketch in the parent function here in blue. The parent function, remember, has the vertex at 0, 0, point at 1, 1, a point at 2, 2, so on and so forth. So there's kind of a sketch of my parent function. Now I'm going to take my new function and I'm going to compare it to what we just looked at. So I've got f of x is equal to the absolute value of x plus 4 minus 2. And I'm going to compare that to the h and k that we just had so that I can talk about the shifts. Okay? So if you recall, the h value, which is right here, was my horizontal shift. So in this case, my horizontal shift is going to be a negative 4 because it's a positive 4, and again, you go the opposite direction for your horizontal shift. And my k, which is right here, is my vertical shift, and you shift exactly as it appears. So in this case, my vertical shift is a negative 2, which gives me a new vertex at negative 4, negative 2. Okay? So that's handy to know that's where your vertex should be. So here's how I'm going to actually do this shifting. Again, I'm going to start at the vertex of my parent function, and I'm going to shift horizontally negative 4. 1, 2, 3, 4. Then I'm going to shift vertically negative 2. 1, 2. And there's my new vertex. Now, I need to take the other 4 points and do the same translations. So I'm going to shift the point at 1, 1, 4 units to the left, and 2 units down. I'm going to take the point at 2, 2, shift it negative 4 units horizontally, and negative 2 units vertically. And there's my new point. I need to do that with the point at negative 1, 1. So I'm going to shift it horizontally 4 to the left, and 2 vertically down. The point negative 2, 2, again I'm going to shift left 4 and down 2. And here is my new absolute value function. And again, you guys should be using your straight edge. And the vertex, if I count it, is at negative 1, 2, 3, 4, negative 2. And it's exactly where we thought it should be. And that's my new vertex. Okay? Now let's take a look at some transformations that actually change the size, shape, and possibly even the orientation of our graph. So here we have something a little bit new. I have an a in my parent function. Well, whenever a is not equal to 1, that's going to change the size, the shape, and possibly even the orientation of your graph. So here's some important information to know. The graph is vertically stretched or elongated if the graph is y is equal to a times the absolute value of x is narrower than the graph of y equals the absolute value of x. And that happens when your a is greater than 1. Sorry, I'm not sure that I made that clear. If the absolute value of your a is greater than 1, then your graph is going to be stretched or elongated. So the graph is narrower than your parent function. If the absolute value of a is less than 1, then the graph is shrunk or compressed, which makes it look wider than your parent function. Let's take a look at some examples. Here I have f of x is equal to 1/2 times the absolute value of x. Now I want to graph this function, but before I do that, let's just go ahead and write this down. F of x is equal to a times the absolute value of x minus h plus k. But you can see we don't have an h or a k, so that means the vertex of this new function is going to be at 0, 0. The only thing I need to do is deal with this 1/2. So again, I'm going to go ahead and I'm going to sketch in my parent function. So I'm going to locate 0, 0, and I'm going to sketch in the parent function in blue. And your teachers might show you a different way to do this, but this is the way I like to do it. And then I'm going to do my new function in red. And this is the way I go ahead and calculate the values for my new function. So again, there was not an h or a k, so I know my vertex is at 0, 0. So I'm going to put that there. This distance between the x-axis and this first point is 1 unit. Now, I am stretching or shrinking my graph by a factor of a half. So if this distance is 1, 1 times a half is half the distance. So my new point is going to be at 1, 1/2. Okay? And then I want to do the same thing over here. I have a distance here of 2, and you know that because this point, the y value is 2. Well, half of 2 is 1, so my new y value is 1. I need to do the same thing on the left side of the graph. This point is at -1, 1. The y unit is 1. Half of 1 is a half, so my new y value is a half. This point is at -2, 2. Again, the y value is 2. Half of 2 is 1, so my new y value in my new function is 1. And I simply draw in the function. So basically all I'm doing there, guys, is I'm taking my y value and I'm multiplying it by that 1/2. And that takes care of my stretch or my shrink. Okay? Now, let's take a look at the next one. On this one, I actually have a stretch or a shrink factor of -3. Let's take a look and see what that -3 does. So again, I'm going to go ahead and sketch in my parent function with those little x's. And I'm going to put it up here. So I've got the point 0, 0, 1, 1, and I'd have one at 2, 2. And over here also. Okay, so now I've got a stretch or shrink factor of -3. So again, this point is at 2, 2. I'm going to take the y value, because that's my distance above the x-axis, and I'm going to multiply that times this -3. So I've got 2 times -3 gives me a -6. So this point that was at 2, 2 is now at 2, -6. So that's way down here. And my point here at 1, 1, I'm going to take the 1 times the -3, and I get -3. So my new point is at 1, -3. Then my vertex is at 0, 0. So if I take 0 times -3, I still get 0. So my vertex remains the same. Okay, then I want to do that on the left side of the y-axis. This point is at -1, 1. If I multiply my y value, which is 1, times -3, I get -3. And some of you have probably figured out that all you have to do is reflect the points across that y-axis for this example, and that's exactly right. So down here, here's my y-axis. This point is 2 units from the y-axis, so I know I'm going to have another point over here 2 units from the y-axis. And if you do the math, this point up here was at -2, 2. The y value is 2. If I take 2 times my factor of -3, I get -6. So this new point should be at -2, -6. And you can count just to make sure. 1, 2, 1, 2, 3, 4, 5, 6. And it does work out. And again, you want to use your straight edge and connect these dots, whoops, in the V shape. Okay? And there is the graph of y equals -3 times the absolute value of x. I have one more example, and then I'm going to have you guys try some. Now, on this one, this is where we put in multiple transformations. And what I'm going to do then is I'm going to write my equation, my general form equation above it, so you can see the transformations. Okay? All right, so my shrink or my stretch is my A value. So in this case, my shrink or my stretch, which also adds to the reflection, is -2. The horizontal shift is your H. So that's going to be the opposite of what it appears, so that's going to be a +1. And then your K is going to be your vertical shift, and in this case, it's 3. Okay, so you should right now know what the vertex is going to be, and that vertex, therefore, is at 1, 3. But let's go ahead and graph it using the transformations and make sure that we get the vertex at 1, 3. So I'm going to put 0, 0 over here. Again, I'm going to sketch in the parent function. And now I'm going to perform my transformations. There's different ways you can do this. Again, your teacher might show you differently. But I am going to go ahead and do my shrink or stretch first, and then the translations. So I'm going to take the vertex at 0, 0, and again I'm going to take my y value, which is the 0, and I'm going to multiply it times a -2. Well, that's still 0. So my shrink or stretch, I keep that one at 0, but now I have to do my horizontal shift and my vertical shift. So now I'm going to do a horizontal shift of 1 and a vertical shift of 3. So here's my new vertex. And again, you can see that it's at 1, 3. Okay, now I need to do the same exact thing with the point at 1, 1. I'm going to take my y value, which is 1, and multiply it times -2, which gives me -2. So the shrink or stretch is now at -2. So from the y-axis, I have a point down here at -2 before the horizontal and vertical shifts. So now I need to do my horizontal and vertical shifts. So I'm going to shift it horizontally 1 and vertically 3. And this gets kind of messy, so maybe I should go ahead and outline these new points in green so you can see them. So those are some new points. Okay. Now I'm going to take this point that's at 2, 2, and that is a comma there, not a negative. This is a +2. So I'm going to take that 2 times the -2, which is my shrink stretch factor, and that gives me a -4. So from the x-axis, I now want to go down -4. 1, 2, 3, 4. But now I need to do my horizontal and vertical shifts. So I do a horizontal shift of 1, vertical shift of 3. Here's my new point. Again, I believe I made a mistake. I'm going to circle that one in green so that we can see it. And let's go back and try to find our mistake. And if you're wondering how I know I made a mistake, it's because I'm looking at these 2 points and they're too close together. And they don't form a line. So let's try this one again. At 1, 1, I had a shrink or stretch of -2, so I went down 2. And then I shifted horizontally 1. But when I shifted vertically, I only did 2 instead of 3, so we're going to cross that point out. And my new point should have actually been right here. Okay, so now those 3 points form a line and it looks much better. Alright, so now the 2 points on the left side of the graph. Now I'm going to do the same thing, but I'm not going to write so much so it's not quite so messy. Okay, so this point is at -1, 1. So I'm going to take that -1 and I'm going to keep it the same. But I'm going to take the +1, the y value, and I'm going to multiply it times a -2. So now, from my x-axis, I need to shift down -2. And then I want to do my horizontal shift of 1 and vertical shift of 3. And here's my new point. And again, I'll outline it in green so we can see it. Now I'm going to take this last point over here that's at -2, 2. And again, that's a +2. I'm going to multiply that times a -2, which gives me a -4. So from the axis, I'm going to go down -4. And then I'm going to do my horizontal shift of 1 and my vertical shift of 3. And here's my new point. Again, I'm going to outline that in green so that we can see it. And I'm going to draw in my lines. And I have my new absolute value function of y equals -2 times the absolute value of x minus 1 plus 3. Now, I'm going to give you 3 that I would like you to try. Here are the 3 I would like you to try. Please write these down, grab a piece of graph paper, and pause while you try each of these, and then I'll show you how to graph each of these, and you can check your answers with mine. Alright, so here we're back again, and hopefully you've tried these 3 problems. And let's go ahead and I'll graph this, and then you should check your answers. So again, I'm going to sketch in my parent function. And then I'm going to do my translations. And in this, I know this is my H, and I know this is my K, so I know my horizontal shift is 2, and my vertical shift is 5. So I'm going to start with the vertex, and I'm going to shift it horizontally 2, 1, 2, vertically 5, 1, 2, 3, 4, 5, and there's my new vertex. Now I'm going to take my second point, shift it horizontally 2 and vertically 5. Take my third point, shift it horizontally 2 and vertically 5. Now I have to take again the last 2 points on the left-hand side of the graph. I'm going to shift horizontally 2 and vertically 5. Shift horizontally 2, vertically 5. And here is my new absolute value function. And again, my vertex is at 2, 5, which can be made from your shifts. Okay? So hopefully you did well on that one. Let's try the next one. Let's see how you did. Alright, so this one has just a stretch or shrink factor of 1/4. So this time I am going to change my scale on my grid a little bit. I'm going to have this be 1/4. This is going to be 1/2. This is going to be 3/4. And this is going to be 1. And the same thing, I'm going to do the same thing for the y-axis for both positives and negatives. Okay? So my parent function, I'm going to sketch that in. There's 0, 0. There's 1, 1 because I'm counting by fourths. And there's 1, 1. Okay? So if I take my y value of my vertex, which is 0, and multiply it by the 1/4, I still get 0. So my vertex for my new function stays at 0, 0. So my new vertex is still right here. And now I'm going to take this point, which is at 1, 1, and I'm going to multiply that y value times 1/4. And 1 times 1/4 is 1/4. So I still have an x value of 1, but my new y value is 1/4. Over here, I'm going to do the same thing. My x value of -1, my y value of 1. I'm going to multiply the 1 times 1/4. And 1 times 1/4 again is still 1/4. So my x value stays -1, my y value is now 1/4. And here is the absolute value. I'm sorry, it's 1/4 of the absolute value of x. So we've just graphed this function. Good job. Let's take a look at the last one I wanted you to do by yourself. And this one, again, has multiple transformations. Again, let's put the parent function in there. I'm not going to talk so much this time. I'm just going to do it. And actually, I don't want the 0, 0 over there. I'm going to put it over here. And my parent function. And then the new function has a shrink stretch of 2, a horizontal shift of -1, a vertical shift of -4. Therefore, my vertex is going to be at -1, -4. Alright, so my shrink stretch is 2, so if I multiply 0 times 2, I get 0. So I'm going to do a horizontal shift of -1 and a vertical shift of -4. There's my new vertex. 1 times 2 is 2, so I'm going to go from the x-axis up 2, but now I have to do my horizontal shift of -1 and my vertical shift of -4. Okay, here my point is at 2, 2 with my stretch shrink. 2 times 2 is 4, so I'm going to go up 4. Now I have to do my horizontal shift of -1 and my vertical shift of -4. And now I'm going to do the same thing over here. 1 times 2 is 2, so I have 2 units above the x-axis. Now I do my horizontal shift of -1 and my vertical shift of -4. This one is 2 units above the x-axis. Multiply that times 2, and it's now at 4, so I go up here to 4. Then I do my horizontal shift of 1 and my vertical shift of -4. And I believe I said that was a horizontal shift of 1, but it was actually a horizontal shift of -1 and a vertical shift of -1. Again, my vertex is at -1, -4, and there's my y equals 2 times the absolute value, x plus 1 minus 4. All right, so let's take a look at transformations just on general graphs. So this is just a random graph that I drew, and I'm going to choose some points. This point's at 0, 0. This point's at 2, 3. And this point at 5, 3. And I want to transform them by a factor of 2. So basically what I'm doing is taking this function, that's my f of x, and I'm transforming it by a factor of 2. So what I'm going to do, just like on the other ones, is I'm going to multiply my y values times 2. So if I take 0 times 2, I get 0. So that one stays at 0, 0. If I take my 3 and multiply it times 2, that changes to 6. So I now have a point at 2, 6. Oh, 2, 6, not 2, 3. And then on this one, same thing. If I multiply this 3 times 2, I now have a point at 5, 6, which would be up here. And that is how you transform just a general graph. Again, that was just a shrink or a stretch. So let's take a look at some shifts. Okay, so you can see on the second graph here that I've already actually done the shifting here, but let's talk about how it works. So this point is at 0, 0. Again, this point is at 2, 3. And I believe the other point I used was at 5, 3. Okay, so I did those same points down here, created the blue line a second time. And then I have a shrink stretch factor of -1. So what that does is that reflects the blue graph over the x-axis, so I now have a point at 2, -3. I have another point at 5, -3. So I've now successfully used the -1 reflection. But now I need to use these two shifts, and you use them exactly like you do in an absolute value function. So I have a horizontal shift of -2 and a vertical shift of +1. So I'm going to take my point at 0, 0 and do a horizontal shift of -2, 1, 2, and a vertical shift of 1, and I end up right here. Okay, now I'm going to take my point that's at 2, -3, and I'm going to shift it horizontally -2 and vertically 1. So I end up here. My point that is at 5, 3, I'm going to shift horizontally -2 and vertically +1. And there I have the new graph again. And you would sketch it in with your pencil. And the shape and the size should look exactly like when you started, but it's been reflected across the x-axis, and it's also been shifted. So some very important things that you need to remember about absolute value functions. You need to remember the vertex is the highest point if the absolute value function opens down, and it's the lowest point if the function opens upward. You also need to remember that in your general form, your H is your horizontal shift, your K is your vertical shift, and the A is the shrink stretch function or shrink stretch value. And if it's a negative, it's also going to act as a reflection. So your teachers may show you some different ways to do this. Hope you have fun with it, because it's actually really kind of a cool thing that you can move these around the graph so easily. See you back in class.